Okay, so Casio PRO-101. Now the PCBs turned up, and I fitted one in here eventually. I mis-soldered some components, but anyway, let's turn it on and go into clear mode, clear the memory, and write a short program, P1, and I will enter 1 and 2, and then 3 equals 1 times 2, and then answer 3. So we're going to multiply two numbers together and display the result. So if we go into comp mode, P1, and it's asking for the first number 5 and the second number 7, and the answer is 35. So if we go back into write mode and do a PR, and you can see 240 steps left. Now at the moment the little PCB, well, it's two PCBs actually, it's a sandwich, but at the moment that is only emulating the lower 128 bytes. I need to put an extra wire on and change the code. So there's some code here somewhere. So if we go into P1, you can see that enter 1, that means there is a program there, and if we check it we get 03, which is enter, 1, which is 1, 14, which is the colon, and 2, so that's the enter 1 2 colon, 3 0 1 is equals, so 3 equals 1, 0 6 is times, 1 times 2 colon, 5 is answer 3, so that's the answer 3 colon, 20 is the end. So the program's in there, so it's there stored inside the RP2040, which is sitting on the board. I'll pop this open a minute. Let's turn it off. I've got the switch out at the moment, it's out of the case, it just falls out when you haven't got the case attached. If I turn it over, can't see a huge amount unless I pull these two boards apart, which you can do now because I've actually there we go. I've actually put the pins and sockets on there, and down the bottom there you can see the replacement for that IC. So it's this PCB sitting in the position for this IC, and on top it's got this small version of a Pico. So there's no difficult soldering on here, it's repairable, people could make them if they wanted to, and they replace TC5006P. Now the only other device, the only other calculator that I've seen with one of those in is the FX202P, but you could replace the chip in there. And you do have USB on here, so you can update the firmware by pulling it apart and attaching USB to this, and then putting new code on there, or looking at the program contents. The only problem really with this versus this is that this takes a lot more power than that. So the calculator as a whole takes about 140 milliamps. If you plug the USB in while it's running, then you can drop that down to the normal operating current. Also, this is not non-volatile, but I think I may be able to do something with that because there's flash inside this chip. You could store programs in the flash, so need to have a think about that. But yeah, so I'm going to have a go now at getting this to do this block of memory over here as well. I've got an extra wire that I can put in, and hopefully it can do the full 256 well, sorry, 2K, isn't it, 256 steps, which is 2K bits actually. There's plenty of RAM in here, plenty of flash as well, so it's way beyond what this calculator had.